Welcome to Z Science, where the universe whispers its secrets, one calm story at a time. Tonight, we drift beyond the Milky Way and into the soft glow of our nearest galactic neighbor, the Andromeda Galaxy. It appears as a faint blur in the night sky, yet it holds more than 1 trillion stars, each one burning quietly across millions of years of distance. In this episode, you'll hear soothing facts about Andromeda, its swirling arms, its ancient suns, and the slow, graceful journey that will one day bring it together with our own galaxy. So lie back, breathe slowly, and let the story of the Andromeda Galaxy guide you into rest. A cosmic lullaby carried across 2 million light-years of space and time. To the naked eye, it appears as a faint blur in the sky, but in reality, it is a colossal system filled with more than 1 trillion stars. Its arms sweep across hundreds of thousands of light-years, glowing softly through the black of space. The light we see began its journey over 2 million years ago, long before the first humans walked the Earth. Every glimmer we catch carries the story of a distant sun, a cloud of dust, or a world no one will ever reach. Inside those vast arms, stars are being born, colliding and fading. Andromeda is not just another point of light, it is our nearest great companion, moving steadily toward us through the void. In billions of years, it will meet the Milky Way and form something entirely new. If you enjoy these calm explorations, you can like, subscribe, or share a thought below. It helps others find their way here too, one sleepy soul at a time. But for now, all you need to do is relax. Allow your breathing to slow, your mind to soften, and let the universe carry you into rest. Let's begin. Andromeda is the closest large galaxy to our own. Among the countless galaxies scattered across the universe, it stands as the nearest great spiral to the Milky Way. It lies just over 2 million light-years away, a short distance on the scale of the cosmos, yet vast beyond imagination. This closeness gives astronomers a rare chance to study a galaxy similar to our own from the outside, revealing how stars, gas, and dust form and move within its arms. Through powerful telescopes, Andromeda's structure becomes clear. Its glowing disk stretches across the night, with lanes of dust cutting through rivers of starlight that spiral toward its core. Every image offers a glimpse of familiar order shaped on a grander scale. Andromeda acts as a mirror, reflecting what our home galaxy might look like to others far away. Its nearness makes it one of the most examined objects in modern astronomy, a living example of how galaxies grow, interact, and evolve over time. In its light, we see not only a neighbor, but a vision of our own distant future written across the sky. Inside Andromeda's immense spiral lies an estimated 1 trillion suns, each one burning with its own intensity, color, and rhythm. These stars fill every region of the galaxy, from the dense central bulge packed with ancient suns to the sweeping spiral arms that curve outward into the quiet dark. Some are massive, brilliant blue giants that live short, fierce lives before collapsing into supernova that seed the surrounding space with heavy elements. Others are tiny red dwarfs that burn dimly but steadily, destined to shine for trillions of years to come. Together, they create a light so powerful that it can be seen across 2 million light-years of emptiness. This enormous population of stars gives Andromeda both its gravity and its grandeur. If even a small percentage hosts planets, then the number of worlds within that galaxy would stretch beyond imagination, perhaps containing more potential habitats for life than there are grains of sand on every beach. On Earth, it can be seen with the naked eye from a dark sky, On a clear, moonless night, far from the glare of city lights, the Andromeda Galaxy reveals itself to anyone patient enough to look. It appears as a small, misty oval in the constellation of Andromeda, a delicate blur that glows softly against the darkness. That faint shimmer is not a trick of vision, but the combined light of over 1 trillion stars. For ancient observers, it was a mystery, ghostly cloud that seemed neither star nor planet, existing quietly on the edge of awareness. Only with the advent of telescopes did humanity begin to glimpse its true nature, discovering that it was not a cloud at all, but an entire galaxy beyond our own. When you find it with your own eyes, you are seeing light that began its journey millions of years before written history. You are looking across both space and time, connecting with the same glow seen by countless generations before you. It was once thought to be a cloud within our Milky Way. For centuries, astronomers believed that the Andromeda Galaxy was a small nebula within our own Milky Way. Early telescopes showed only a faint hazy patch of light, leading observers to conclude it must be a cloud of gas or dust. In the 17th and 18th centuries, it was known as the Andromeda Nebula, one of many fuzzy objects catalogued by early stars. That belief persisted until the 1920s, when Edwin Hubble used the 100-inch telescope at Mount Wilson Observatory to study it more closely. Within the haze, he found a special kind of star known as a Cepheid variable. Its rhythmic brightening and dimming reveal its distance. His calculations showed that Andromeda lay far outside our galaxy, millions of light years away. The discovery was revolutionary. It proved that the universe was far larger than anyone had imagined, filled with galaxies beyond number. The Andromeda Nebula was reborn as the Andromeda Galaxy, and humanity's understanding of the cosmos changed forever. Its light takes more than 2 million years to reach us. When we look at the Andromeda Galaxy, we are not seeing it as it exists right now, but as it appeared more than 2 million years ago. Every particle of light that reaches our eyes began its journey long before the first humans walked the Earth. That light crossed the cold, silent gulf between galaxies, carrying with it the record of ancient suns. Some of those stars may have already faded, exploded, or transformed into white dwarfs and black holes, yet their glow continues onward, undisturbed. Observing Andromeda is like looking through time itself. The light that now enters our telescopes began its voyage when the ancestors of modern humans were shaping stone tools and watching distant fires on the plains of Africa. Each observation of Andromeda is therefore both a scientific act and a moment of quiet connection to the deep past. Its radiance is a message from history. Arriving unchanged across the ages, it is approaching the Milky Way at astonishing speed. Although Andromeda appears still and serene in the night sky, it is actually racing toward us at a speed of more than 200 kilometers every second. Astronomers detected this motion by studying the light emitted from its stars. That light is slightly shifted toward the blue end of the spectrum, revealing that the galaxy is moving closer. This phenomenon, called blue shift, is unusual among galaxies, since most are receding as the universe expands. Andromeda is one of the few heading directly toward us, drawn by the immense pull of gravity between the two great systems. The approach is invisible to our eyes, unfolding slowly across billions of years. Yet it is relentless. Nothing can halt this cosmic drift, already written into the motion of space itself. In this quiet advance, we can see both the future of our galaxy and the slow choreography of gravity that shapes the universe. Astronomers have already mapped its collision course with us. Using space observatories such as Hubble and Gaia, scientists have measured Andromeda's motion across the sky with remarkable precision. These observations reveal that it is not simply passing by, but is locked on a direct path toward the Milky Way. Computer simulations trace this trajectory far into the future, showing how gravity will stretch both galaxies into luminous tidal streams before they finally merge. The first close encounter will happen roughly 4 billion years from now, followed by a slow, spiraling union that could take billions more to complete. During that time, the night skies of any surviving worlds will be transformed, filled with vast arcs of stars stretching across the horizon. Mapping this collision has given humanity a vision of its far future. Written in the laws of physics, quiet but certain fate, patiently waiting on the grand time scale of galaxies. When it merges with the Milky Way, a new galaxy will form. The eventual meeting of the Milky Way and the Andromeda Galaxy will not be an explosion, but a slow and graceful merging that unfolds across billions of years. Their spiral arms will twist and stretch into long rivers of starlight as gravity pulls them together. Most stars will never collide directly, because the space between them is vast, but their paths will shift, weaving new orbits within the growing system. Over time, the two galaxies will combine into a single enormous elliptical galaxy with a bright, dense core and broad, diffused edges. From any surviving planet, the sky will be filled with dazzling light as stars from both systems mingle across the heavens. This merging will mark the next chapter in the life of our cosmos, turning two great spirals into one shining whole that will endure long after the Milky Way's original shape is gone. Astronomers have already named the galaxy that will emerge from the union of the Milky Way and the Andromeda Galaxy. They call it Milkomeda, a blend of the two names that captures the shared legacy of both systems. This new galaxy will likely contain several trillion stars and span hundreds of thousands of light years. At its heart, the supermassive black holes from both galaxies will drift together, spiraling inward until they merge in an immense release of energy. Milkomeda will shine as a smooth, rounded galaxy with a brilliant central glow to any distant observer. It will appear calm and symmetrical, an elegant monument to the forces that built it. Within its light will lie the combined history of two galaxies that once faced each other across the dark. It is a reminder that even in the quiet of space, everything is still in motion and nothing lasts unchanged forever. Its spiral arms stretch across hundreds of thousands of light years. The Andromeda Galaxy is one of the largest spiral galaxies ever measured, its disk spanning more than 200,000 light-years from edge to edge. The spiral arms that define its beauty wind outward from a bright central bulge, forming vast lanes of stars, gas, and interstellar dust. These arms are not fixed structures, but moving waves of density that ripple through the galaxy like tides. As these waves travel through regions rich in gas, they compress the material, triggering bursts of star formation that light the arms with clusters of young blue stars. Between them lie darker bands of dust that block and scatter light, adding contrast and depth to the structure. Observing these arms through powerful telescopes reveals how matter flows, collapses, and renews itself over immense timescales. The delicate balance of order and chaos within those spirals tells the story of how galaxies remain alive, forever reshaped by the gravity that binds them. The Andromeda Galaxy dwarfs our Milky Way in size. When viewed through a telescope, Andromeda's vastness becomes almost difficult to comprehend. Its sprawling disk stretches more than 220,000 light-years from end to end, nearly twice the diameter of our Milky Way. It contains over 1 trillion stars, and its faint halo extends even farther, fading gradually into the intergalactic dark. If our eyes could see the full extent of Andromeda's glow, it would appear several times wider than the moon in our night sky. Its sheer scale reminds us that galaxies are not tidy spirals of light, but sprawling cosmic cities made of countless suns, nebulae, and clouds of invisible matter. Compared to Andromeda, our Milky Way feels like a smaller sibling orbiting within the same family of stars. Both galaxies bound by gravity and destined to one day meet in a magnificent cosmic union. Its core glows with the light of billions of ancient suns. At the heart of the Andromeda Galaxy lies a glowing, compact region that blazes more brightly than almost anywhere else in its vast disk. The light here is soft and golden, the combined radiance of countless stars that have burned for billions of years. Most of them are older than our Sun, small and steady, their fuel slowly fading. These ancient stars crowd together so densely that in some regions they are only a fraction of a light-year apart. From that crowded hub, light travels for more than 2 million years before reaching us. The core's golden color tells astronomers that it is home to an older stellar population, where the frantic birth of new stars has long since quieted. In a way, Andromeda's heart is a living fossil, a preserved remnant of its earliest days. Glowing quietly across the ages, there may be a supermassive black hole at its center. Astronomers studying Andromeda's core have detected stars whipping around an unseen object at astonishing speeds. The only explanation that fits the data is a supermassive black hole, millions of times more massive than our Sun. Its gravity is so intense that even light cannot escape once it crosses the black hole's boundary. Around it, stars dance in tight orbits, creating a gravitational ballet that has been unfolding for billions of years. The space near this black hole is likely filled with swirling disks of hot gas and dust, glowing brightly as they spiral inward, though invisible to the eye. The black hole's presence can be inferred through the motion of nearby stars and the radiation emitted by its surroundings. It is a silent engine of gravity, shaping the heart of the Andromeda Galaxy and influencing the rhythm of everything that orbits within its grasp. Some believe there might be 2 black holes there, locked together. When astronomers examined the very center of Andromeda with high-resolution instruments, they noticed something peculiar. The light did not come from a single bright point, but from 2. This led to the hypothesis that Andromeda might host not 1, but 2 supermassive black holes orbiting one another in a slow, immense dance. Such a pair would be the relics of a long-ago galactic merger when 2 ancient galaxies collided and their central black holes began spiraling together. Over cosmic time, they may draw closer, releasing waves of gravitational energy that ripple through space-time itself. Eventually, they could merge into an even larger black hole, if true. This hidden partnership, deep in Andromeda's core, offers a glimpse of our own galaxy's future. For the Milky Way also harbors a massive black hole that may one day meet its Andromedan counterpart in a similar cosmic embrace. Its structure reveals a history of cosmic cannibalism. The more we study Andromeda, the more evidence we find that it has built itself through countless acts of cosmic consumption. Its halo contains stars of many origins, its disk is warped and rippled, and its outer regions shimmer with faint debris from galaxies it has devoured. Each sign points to a long, evolutionary journey shaped by merger after merger. Astronomers now see Andromeda not as a single entity, but as the accumulated remains of dozens of smaller galaxies. Even its spiral arms may have been reshaped by these encounters. This form of galactic cannibalism is not violent in the human sense, but is part of the slow metabolism of the universe. Galaxies grow by absorbing others, recycling their stars and gas into new generations of light. Andromeda's beauty, therefore, is also a story of transformation through time. The galaxy is surrounded by mysterious dark matter. Only a fraction of Andromeda's mass comes from visible stars and gas. The rest is made of something unseen, something that does not emit or absorb light. Astronomers call it dark matter. Its existence is revealed only through its gravitational influence, which holds the galaxy together and shapes the motion of its stars. Without dark matter, Andromeda's outer regions would fly apart. The idea that most of a galaxy's mass is invisible challenges our understanding of the universe. Dark matter may consist of exotic particles that interact only through gravity, or it may be a sign of deeper laws of physics not yet known. Whatever it is, dark matter surrounds Andromeda like a vast, transparent cocoon, shaping its fate and linking it to every other galaxy across the cosmos. Through the unseen web of gravity that binds all things, dark matter outweighs its visible stars by far. When scientists calculate the total mass of Andromeda, they find that its luminous stars and gas account for only a small portion. The rest must be dark matter, outweighing the visible components by perhaps 10 to 1. This invisible substance forms a halo that extends far beyond the spiral arms, influencing how the galaxy spins. Without it, the outer stars would move much more slowly than they do. Instead, their high speeds reveal a massive hidden presence. Dark matter acts as a cosmic scaffold, giving galaxies their structure and stability. Though undetectable directly, its effects are everywhere. In this way, Andromeda is not just a collection of stars, but also a vast gravitational mystery. Its luminous disk floats within an unseen sea of matter, an enduring reminder that most of the universe remains beyond the reach of human sight. The motion of its stars reveals the presence of that unseen mass. When astronomers measure how fast stars move around Andromeda, they discover something astonishing. The outermost stars orbit almost as quickly as those near the center, even though there is far less visible matter to pull on them. This means something unseen must be providing the extra gravity needed to hold the galaxy together. That hidden force is attributed to dark matter. By mapping the rotation speeds at different distances from the core, scientists can trace how this invisible material is distributed throughout the galaxy. The smooth, consistent motion of Andromeda's stars paints a picture of a vast dark halo surrounding it, extending far beyond the visible spiral. Through careful observation, Andromeda has become one of the best examples in the universe for understanding how dark matter shapes the grand architecture of galaxies. Andromeda has vast regions filled with glowing hydrogen gas. Across Andromeda's spiral arms lie immense clouds of hydrogen, the raw material from which new stars are born. When starlight energizes this gas, it glows faintly in shades of pink and red, forming nebulae that stretch across thousands of light years. These glowing regions mark sites of active star formation. Within them, gravity pulls denser clumps of gas together until they ignite as new suns. Observing these hydrogen clouds allows astronomers to see Andromeda's ongoing life cycle in action, even in a galaxy so old and vast. creation has not ceased. The light from these nebulae travels for more than 2 million years to reach us, offering a glimpse into Andromeda's present as it was long ago. The beauty of these glowing clouds reminds us that even in the silent depths of space, new light is always being born. These regions are nurseries where new stars are born. Within Andromeda's great clouds of hydrogen, tiny pockets of gas collapse under their own gravity. As the pressure and temperature rise, nuclear fusion ignites and a star is born. These stellar nurseries are turbulent yet delicate, filled with glowing gas and dark lanes of dust that weave through them like smoke. Many of these newborn stars form in clusters, lighting up their surroundings in shimmering color. Over time, their intense radiation and stellar winds sculpt the gas into intricate shapes, carving out cavities and filaments. Some of these young stars are massive and short-lived, destined to explode as supernova within a few million years. Others will shine steadily for billions. Observing these regions in Andromeda allows astronomers to witness the same process that once created our own. Sooner, reminder of how the cycle of cosmic birth continues. Everywhere in the universe, enormous bubbles of hot gas stretch far above its disk. High above Andromeda's spiral arms, astronomers have detected vast bubbles of hot gas, each tens of thousands of light-years across. These immense structures glow in X-ray light, evidence of powerful energy released within the galaxy's core and star-forming regions. They may have formed from waves of supernova, explosions, or intense bursts of stellar winds that pushed gas outward over millions of years. These bubbles act as a kind of galactic exhale, venting energy and matter into the surrounding halo dot. Studying them reveals how galaxies regulate their own growth, balancing creation with release, though invisible in ordinary light. These colossal forms mark Andromeda's dynamic, life-breathing heat and motion into the quiet dark. They show that even a galaxy can pulse and change, leaving vast imprints on the space around it. The bubbles may have been created by violent starbursts. Occasionally, Andromeda experiences episodes when star formation surges dramatically. These events, known as starbursts, flood the galaxy with energy. As massive young stars form and die in quick succession, their winds and explosions combine to drive hot gas outward. The result is the creation of giant bubbles that expand far above and below the galactic plane. These bubbles are the footprints of Andromeda's most energetic moments, each one carrying material back into the galaxy's halo. Over time, this process enriches the surrounding gas with heavy elements forged inside stars, providing the ingredients for future generations of light. The existence of these bubbles shows that galaxies are not static systems, but living ecosystems that breathe, burn, and renew themselves. Andromeda, like all galaxies, carries the memory of these outbursts within the faint structures that surround it. Supernova explosions continually reshape its interstellar medium. Across the vast expanse of the Andromeda Galaxy, individual stars live out their lives quietly for billions of years. Yet every so often, one of them ends in a spectacular collapse known as a supernova. These titanic explosions release more energy in a single instant than our Sun will emit during its entire lifetime. In Andromeda, thousands of such events have occurred over cosmic time, each one stirring and enriching the galaxy's interstellar medium. The shockwaves from these explosions ripple outward, compressing nearby gas clouds and triggering new waves of star formation. Heavy elements like iron, gold, and oxygen forged in the hearts of dying stars are flung into space, becoming part of future worlds yet to form. Through this ongoing cycle of death and rebirth, Andromeda's structure and composition are continually renewed. Its luminous beauty, visible from millions of light years away, is built upon this ancient rhythm of cosmic transformation. Its spiral arms sparkle with thousands of young blue stars. When seen in full color through telescopes, Andromeda's spiral arms glimmer with the bright sapphire light of youthful stars. These young suns are massive, hot, and short-lived, burning with fierce intensity before fading into supernova within only a few million years. They form in clusters within vast clouds of hydrogen gas, where gravity pulls matter together until fusion begins. The ultraviolet light they emit floods their surroundings, causing nearby gas to glow and outlining the graceful shape of Andromeda's arms. These blue stars serve as markers of the galaxy's ongoing creativity, the places where it is still forming new light. Though they live fast and die young, they illuminate the paths along which the galaxy continues to evolve. When we observe Andromeda's glowing spiral arms, we are seeing the energy of cosmic youth scattered across the night. Each blue point a brief and brilliant moment in an ancient story. Its center is filled with older yellow and red stars. At the heart of the Andromeda Galaxy lies a contrasting world from its radiant spiral arms. Here, the stars are older, cooler, and burn with soft hues of gold and red. These ancient suns have long since exhausted much of their hydrogen fuel and now shine more gently, their light steady but subdued. Together, they create the warm amber glow that dominates Andromeda's central bulge. Over billions of years, star formation has slowed in this region, leaving behind a dense, stable population that moves in complex orbits around the galaxy's hidden black hole. Studying this central cluster gives astronomers clues to Andromeda's earliest history, showing what remains after the storms of star birth have passed. The contrast between the brilliant blue arms and the golden heart tells a story of time itself, revealing how galaxies mature, age, and settle into quiet luminosity as their energy gradually softens. Star formation is not uniform across its disk. Although Andromeda's spiral structure may appear symmetrical, star formation within it occurs unevenly. Some regions blaze with clusters of newly born stars, while others are comparatively dark and quiescent. This variation is shaped by the distribution of gas, dust, and magnetic fields across the galaxy's disk. In areas where cold hydrogen is abundant, gravity can easily trigger new bursts of star birth. Elsewhere, the gas may be too thin or too hot to collapse. Waves of density created by spiral arm motion pass through the disk and compress the gas in rhythmic cycles, igniting stars along narrow, curved bands. Observing these patterns helps astronomers understand how galaxies breathe, forming stars in pulses rather than continuously. Andromeda's uneven tapestry of light reveals that, even on a galactic scale, creation unfolds in complex rhythms, with calm regions balancing the brilliant outbursts of cosmic energy that define its spiral beauty. The inner regions have slowed while the outskirts keep shining. In the central parts of the Andromeda Galaxy, the raw material for star formation has gradually been consumed. Most of the gas there has either turned into stars or been blown outward by past stellar winds. As a result, the inner disk now glows, primarily with older, longer-lived stars whose light is steady but subdued. In contrast, the galaxy's outer regions remain rich in cold hydrogen gas, allowing new stars to continue forming far from the center. This difference creates a kind of temporal layering within Andromeda, where the ancient heart coexists with a youthful rim. Studying this contrast allows astronomers to trace how galaxies evolve from active star-forming systems into calmer, mature structures. The bright edges of Andromeda remind us that even an old galaxy still carries pockets of vitality, where the cosmic cycle of birth and renewal quietly continues among the outermost arms. Dust lanes swirl through the spiral arms like smoky ribbons. When viewed through powerful telescopes, the luminous arms of Andromeda are streaked with intricate dark lines. These are lanes of interstellar dust composed of tiny grains of carbon and silicate left behind by dying stars. They absorb and scatter starlight, creating the appearance of smoky ribbons coiling through the glowing spiral. Within these dust lanes lie the cool, dense regions where stars are born. Far from being mere shadows, they are the fertile soils of the galaxy. Their complex shapes trace the movement of gas under Andromeda's gravity, revealing how matter flows and gathers along the spiral arms. Seen in infrared light, these lanes come alive, glowing faintly with warmth as they absorb radiation from nearby stars. Through their delicate patterns, we glimpse the quiet choreography of cosmic creation, the same process that once gave rise to the sun, the earth, and every atom of life we know. Infrared telescopes reveal these dark lanes, glowing faintly with heat. To the naked eye, or through ordinary optical telescopes, Andromeda's dust lanes appear as shadows against the light of its stars. But when astronomers observe in the infrared, those shadows vanish, replaced by a soft, luminous glow. The dust itself, warmed by nearby starlight, radiates faint heat that can only be detected at longer wavelengths. Using infrared observatories such as the Spitzer and James Webb Space Telescopes, scientists can peer through the veils of dust to see what lies beneath and covering young stars, still wrapped in their birth clouds. These images reveal hidden architecture, showing how dust and gas weave together to shape its spiral form. What once looked like darkness becomes a tapestry of gentle warmth. The view reminds us that even in the coldest reaches of space, every particle carries energy, every shadow hides light, and every silence hums with unseen activity. Its ultraviolet glow shows where the youngest stars live. The Andromeda Galaxy radiates not just invisible light, but across the full electromagnetic spectrum. When astronomers examine it in ultraviolet wavelengths, a different picture appears. The spiral arms blaze with bright, energetic patches, where massive young stars are clustered together. These newborn stars emit vast amounts of ultraviolet radiation, heating and shaping the surrounding gas. By mapping this glow, scientists can trace the galaxy's most active star-forming regions and measure how rapidly it is still creating new stars. The ultraviolet image of Andromeda looks almost skeletal, revealing its inner framework of stellar nurseries, glowing like embers within the spiral. Each bright region is a cosmic cradle, less than a few million years old. To see Andromeda in ultraviolet light is to watch it live and breathe in real time, a reminder that even ancient galaxies continue to create new light with steady, patient energy. Radio waves expose cold gas waiting to collapse into stars. Long before new stars ignite, their raw material exists as vast clouds of cold hydrogen. These regions do not shine in visible light, but they emit faint radio signals that astronomers can detect using giant radio telescopes. By tuning to the specific frequency of neutral hydrogen, scientists can map where this gas lies within Andromeda. The resulting image reveals enormous spiral patterns extending well beyond the visible disk, showing that Andromeda's structure continues far into space. This cold gas is the galaxy's reserve of future starlight, material that will one day collapse under gravity to form new suns and planets. Observing it allows astronomers to predict where the next generation of stars will appear. The radio view of Andromeda is therefore like a blueprint of its future, a quiet, invisible foundation for the brilliant stars that will one day light its arms again. Andromeda shines brightly in every wavelength of light. From radio to gamma rays, the Andromeda Galaxy glows across the entire electromagnetic spectrum. Each wavelength reveals a different layer of its story. Radio waves show its cool gas and vast structure, while infrared light reveals the warmth of dust and newly formed stars. Visible light displays the grand spiral itself. Ultraviolet marks regions of high-energy youth, and X-rays uncover the violent remnants of exploded stars. Together, these layers form a complete portrait of a galaxy alive with complexity. No single view tells the whole truth. It is only by combining all these wavelengths that astronomers can see Andromeda's full personality. From the calm of its outer disk to the fierce energy near its core, to look upon it is to gaze across the entire spectrum of cosmic life, from birth to death, woven together in one vast celestial masterpiece. From space, it is one of the most studied galaxies in the universe. Orbiting observatories have devoted countless hours to observing Andromeda. The Hubble Space Telescope has captured sweeping mosaics of its spiral structure, while instruments aboard the Chandra Observatory and the James Webb Space Telescope have examined its energetic core and dusty outskirts in exquisite detail. Andromeda serves as a nearby laboratory for understanding galaxies across the cosmos. Because it is close and similar in structure to our Milky Way, it allows scientists to study processes that would be impossible to observe clearly in more distant systems. Every wavelength, every image, adds to a collective understanding of how galaxies live, age, and interact. Andromeda is more than a distant smudge in the night sky, is a cornerstone of modern astronomy, a benchmark against which we measure our knowledge of the universe and our place within its grand design. Early astronomers debated fiercely whether it was within our Milky Way. Before the 20th century, no one knew for certain what Andromeda truly was. Through early telescopes, it appeared as a faint, cloudy patch, sometimes called the Great Andromeda Nebula. Many astronomers believed it lay within our own Milky Way, a nearby cluster of stars shrouded in mist. Others suspected it might be something far larger, perhaps an entire island universe beyond our own. This debate became one of the most passionate questions in the history of astronomy. Without precise instruments to measure distance, the truth remained hidden for centuries. Andromeda was both familiar and mysterious, visible to the eye, yet incomprehensible in scale. The argument over its nature reflected humanity's growing curiosity about the universe, a longing to understand whether our galaxy was unique or part of something much greater. That uncertainty persisted until a single observation finally settled the question once and for all. A famous photograph settled the argument once and for all. In the early 20th century, astronomers began to capture long-exposure photographs of the night sky. One of these images, taken by Edwin Hubble using the Hooker telescope at Mount Wilson Observatory, revealed something extraordinary within the Andromeda Nebula. Embedded among its glowing spirals were faint, pulsing points of light known as Kithide variable stars. By measuring their brightness and the rhythm of their pulses, Hubble could calculate their distance. The result was staggering. These stars lay far beyond the boundaries of our Milky Way. The Andromeda Nebula was not a nearby cloud of gas, but a vast galaxy in its own right. That single photograph changed astronomy forever, transforming a mystery into a revelation. It opened humanity's eyes to the true scale of the cosmos, showing that our galaxy was merely one among countless others scattered through the immense fabric of the universe. Edwin Hubble proved it was far beyond our galaxy's edge. Using the light from Cepheid variable stars, Edwin Hubble calculated that Andromeda was more than 2 million light-years away. At that time, such a distance was almost unimaginable. The discovery shattered the long-held belief that the Milky Way contained all of creation. Andromeda became the first confirmed galaxy beyond our own window into the vastness of the universe. Hubble's precise measurements marked the birth of modern, extragalactic astronomy. His work not only revealed the true nature of Andromeda, but also hinted at a much larger truth. That space was filled with galaxies of every shape and size, stretching endlessly in all directions. This breakthrough transformed humanity's view of its cosmic home. For the first time, we understood that we were part of an immense and expanding universe, filled with countless other worlds glowing in the dark. That discovery changed our understanding of the universe forever. When Edwin Hubble announced his findings in the 1920s, the scientific world was stunned. Until then, most astronomers believed that the Milky Way represented the entire cosmos. The realization that Andromeda was another galaxy far beyond our own expanded the known universe by an almost inconceivable amount. Overnight, the cosmos grew from a single island of stars into a vast ocean filled with countless galaxies. This discovery redefined humanity's place in existence, transforming our perception of scale, time, and possibility. It also paved the way for the discovery that the universe itself is expanding, a concept that continues to shape cosmology today. Andromeda thus became a symbol of perspective, a reminder that even the most familiar patch of sky can conceal wonders beyond imagination, waiting patiently for the moment when human curiosity grows sharp enough to see them clearly. It is one of the few galaxies moving toward us instead of away. In a universe that is expanding, most galaxies are receding from one another, their light stretched toward the red end of the spectrum. Andromeda is a striking exception. Its light is slightly blue-shifted, showing that it is approaching rather than retreating. This makes Andromeda a rare and valuable object for study. Its motion toward us demonstrates that local gravity can overcome the overall expansion of space. The Milky Way and Andromeda are bound together within a small gravitational pocket of the cosmos known as the local group, where their mutual attraction outweighs the pull of cosmic expansion. This blue-shifted signal tells us that their meeting is certain. The two great spirals are already locked into a slow, graceful approach dance that will ultimately reshape both galaxies into one. The collision will not happen for billions of years. Despite Andromeda's high speed, the immense distance between our galaxies means their encounter will unfold on an almost unimaginable timescale. Astronomers estimate that the first close pass will occur roughly 4 billion years from now, with full merger taking place a few billion years after that. By then, the Sun will be nearing the end of its life, and Earth may no longer be habitable. Yet for any future observers elsewhere, the night sky will become a spectacular sight. Over millennia, Andromeda will grow larger and brighter, eventually filling the heavens with its spiral form. Then, as the galaxies begin to merge, their stars will be scattered into vast tidal streams, creating new shapes that glow across the cosmos. This slow, luminous ballet will not bring destruction, but transformation, turning to galaxies into a single, radiant whole. When they meet, most stars will pass by each other untouched, though the Milky Way and Andromeda both contain hundreds of billions of stars. The distances between those stars are enormous. When the galaxies collide, the vast majority of them will not physically collide. Instead, they will simply drift past one another, guided only by gravity. The encounter will be dramatic, but largely silent. The greatest changes will occur in the overall structure of both galaxies, their spiral arms stretching, twisting, and finally merging into a new elliptical shape. Clouds of gas and dust will collide, sparking bursts of new star formation that light up the merging system. It is a cosmic paradox, a collision that creates rather than destroys, weaving chaos into beauty over timescales that defy comprehension. The two galaxies will merge into a single, larger system. Over billions of years, gravity will draw the Milky Way and Andromeda together until they become one. Their spiral arms will dissolve, their stars settling into a vast, smooth, elliptical shape. Astronomers call the future galaxy Milkomeda, name that joins both legacies into one dot. At the center of this new system, the supermassive black holes from each galaxy will spiral inward and merge, releasing powerful gravitational waves that ripple across the universe. The night sky, viewed from any surviving world, will be filled with streams of light from billions of stars newly intermingled. This merging is not an end but a transformation, the natural continuation of cosmic evolution. Galaxies are living systems that grow through encounters, absorbing one another, blending histories and matter until something larger and more intricate is born. Milkomeda will be their shared monument, glowing quietly where two spirals once stood apart. Astronomers have simulated the collision in vivid detail. Using supercomputers, scientists have recreated what will happen when the Milky Way and Andromeda meet. These simulations trace the motions of billions of stars, gas clouds, and dark matter particles, showing how gravity sculpts every stage of the event. At first, the galaxies will approach slowly, passing through one another like ghosts. Their spiral arms will distort and fling out long tidal tails filled with stars. After this initial encounter, they will drift apart for a time before falling together again. Each pass will bring them closer until they finally merge. The simulations predict that the resulting galaxy will resemble a large elliptical system, bright, round, and calm, its original spirals erased. Watching these models unfold is like seeing the distant future of our night sky played out in slow motion. A vision of beauty born from the quiet, patient work of gravity. Our solar system might drift to a new position within the merged galaxy. When the Milky Way and Andromeda combine, the Sun and its planets will not be destroyed, but their position will change dramatically. As the galaxy's gravitational fields merge, stars will be flung into new orbits. Our solar system may be carried farther from the center or drawn closer, depending on the exact path it follows through the chaos. The night sky would no longer show a single bright band of stars, but a dome filled with scattered light from every direction. Though the event will be spectacular on a cosmic scale, for any distant descendants who might still exist, it will unfold so gradually that it would be imperceptible within a single lifetime, a quiet reshaping of the heavens, witnessed over eons rather than moments.